In the summer of 2023, I taught a 5-week class on intelligent design at Faith Lutheran Albuquerque, organized by Pastor Mark Behanna. A report on this class was posted at the Discovery Institute website on July 25, 2023. If you go to evolutionnews.org, you can find this report with a link to the videos of the 5 sessions. However, since no one wants to watch 5 hours of videos, I've created this 1-hour video which summarizes the main points made and includes the main videos we watched. The video, A Summary of the Evidence for Intelligent Design, begins with a short discussion of the local fine-tuning of conditions on Earth, but then quickly moves to the more powerful evidence from the global fine-tuning of the laws and constants of physics and the initial conditions of our universe.
It is well known and well accepted in scientific circles that the conditions on our planet are extremely fine-tuned for life. The Earth is just the right size, it is just the right distance from the Sun, our Sun is the right type of star, our atmosphere has many rare and lucky features. The list goes on and on. Of course, materialists have a plausible explanation for this. There are many planets in the universe, but only a very few are suitable for life, and we are here because our Earth is one of those rare planets. At least it would be a plausible explanation if the materialist assumptions were plausible, that once you have a planet where conditions are just right, there is a reasonable chance that life would spontaneously arise and intelligent beings would spontaneously evolve over time. But we will see that these assumptions are not plausible. It is also widely accepted that not only is our Earth an ideal planet for life to thrive, but our whole universe is fine-tuned for life. The smallest changes in most of the basic constants of physics, the gravitational constant, Planck's constant, the charge and mass of the electron, and so forth, or of the initial conditions at the Big Bang, would have led to a universe where no conceivable form of life could have arisen. Stephen Hawking, in A Brief History of Time, writes, "The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life." How do materialists explain this? There must be many universes with many different laws and constants and initial conditions, and we are here because our universe is one of those rare universes where the conditions are just right for us to be here. A.J. Leggett lists some of the fine-tuned properties of our universe in The Problems of Physics and concludes, "The list could be multiplied endlessly, and it is easy to draw the conclusion that for any kind of conscious beings to exist at all, the basic constants of nature have to be exactly what they are, or at least extremely close to it." The anthropic principle then turns this statement around and says, in effect, that the reason the fundamental constants have the values that they do is because otherwise we would not be here to wonder about them. Paul Davies, in Other Worlds, writes, "If we believe there are countless other universes, either in space or time, or in superspace, there is no longer anything astounding about the enormous degree of cosmic organization that we observe. We have selected it by our very existence. The many universes theory does provide an explanation for why many things around us are the way they are. Just as we can explain why we are living on a planet near a stable star by pointing out that only in such locations can life form, so we can perhaps explain many of the more general features of the universe by this anthropic selection process. This time, there is no evidence, there can never be any evidence, that there are other universes out there with the same laws of physics but random values for the basic constants, or perhaps random laws of physics also. So the explanation that our universe is just right because otherwise we would not be here to wonder about it is completely unscientific. It is interesting that those who for many years have ridiculed religious believers for imagining that there is another universe, another dimension out there with better conditions awaiting us, have now been reduced by the evidence for fine-tuning to inventing not one, but countless other universes with different conditions. By the way, a number of scientists, for example, biochemist Michael Denton in his 2016 book Firemaker, and physicist Robin Collins in a chapter of a 2018 Oxford University Press book, The Argument from Physical Constants, the Fine-Tuning for Discoverability, are now showing us that the conditions on Earth and the laws of physics are not only fine-tuned for the survival of intelligent beings, they are also fine-tuned for the development of technology and for scientific discovery. Astronomer Guillermo Gonzalez, in his book The Privileged Planet, has shown that the Earth is not only well designed for human survival, it is also ideally situated for viewing the rest of the universe. These fine-tunings are interesting because they cannot be explained by the conditions were just right because otherwise we would not be here to wonder about it arguments. We would still be here to wonder if the conditions on Earth and the properties of the chemical elements and compounds were not so finely tuned to make possible the development of technology and scientific discovery. The only explanation for these fine-tunings is they are gifts from our designer to challenge and entertain us.
There are many examples known of fine-tuning, but the most spectacular example was discovered by Nobel Prize winner Roger Penrose and is mentioned in the video below. It relates to the initial low entropy of the universe and required a precision of 1 part in about 10 to the n, where n is equal to 10 to the 123. N is itself larger than the number of atoms in the universe.
From galaxies and stars, down to atoms and subatomic particles, the very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would again be life-prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are three live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life-permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life-prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life-permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really, 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 really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So, in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe, inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance, the best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common-sense interpretation of the facts suggests that a superintellect monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.
In the video interview below, Roger Penrose says he is agnostic toward design, yet he doesn't appeal to the multiverse because if the multiverse argument could explain fine-tuning, we ought to be observing a much different universe than we do. This appears to be the same objection raised by others, including Michael Behe in The Edge of Evolution. On the finite random multiverse view, we should very likely live in a bare-bones world with little or nothing in life beyond what's absolutely required to produce intelligent observers.
Well, in the contemporary literature on fine-tuning, there are basically three explanatory options. Either physical necessity, that these constants and quantities must have the values they do, that it's not contingent, or secondly, chance, and the form that this normally takes would be a kind of multiverse hypothesis, and then an appeal to an observer selection, self-selection effect, that we can only observe universes that are finely tuned for our existence, so we shouldn't be surprised that somewhere in the infinite multiverse that we should appear in such a universe. And then the third one would be design, that there is an intelligence that has designed the universe. And Roger's a special contribution, I think, to this has been to place a very significant objection and question mark behind the explanation of the multiverse hypothesis with the self-selection effect. Because if we were just a random member of a multiverse, we ought to be observing a much different universe than we do.
I want to come to that. I mean, first of all, on this question of fine-tuning, which again, we might be worth just spelling out a little bit for the audience. Yes. You've yourself have contributed interestingly to this. There's a certain aspect of reality, the initial low entropy distribution of mass and energy. Now, yes. Without getting too technical at this point, this is essentially the idea you were sort of alluding to earlier, that at that very earliest moment, that singularity in Big Bang cosmology, there's an incredible amount of order versus the disorder, the entropy that appears later on, that needs to be there in order for a life-sustaining universe to be possible. In fact, you put this extraordinary number on it of the precision needed to be 1 in 10 to the power of 10 to the power of 123, which I'm told is, if you were to try to write that down there and you put a 0 on every single particle in the observable universe, you still wouldn't have enough zeros.
Nowhere
on this.
Close.
and so yes. This is mind-boggling stuff, but it appears that as though someone, as you know, who was it who said that someone's been monkeying with the physics? Hoyle. Fred Hoyle said it looks as though, as Bill has said, some sort of design is there to ensure that we got here. Now, what do you say to that idea?
Well, I'm agnostic, I would say, on that one. You see, it's not clear to me. I mean, people talk about well, even the mass ratio between the proton and the neutron, and the fact that the neutron is just a little bit more massive than the proton, and it goes that way rather than the other way around, and so on. But it's very difficult to, since we only know one kind of life, you see, or one kind of the production of consciousness, it may be very rare throughout the universe. I mean, the numbers may not all be all that good. You see, you can imagine fiddling with them so that there were consciousnesses all over the place. You see, I don't know. You see, we don't know enough about that, and there are some nice examples from science fiction which show different I like the one, Fred Hoyle's idea of the black cloud, you see, where this was a completely different way of imagining a conscious being, which was this huge cosmic cloud which communicated, I guess, by electromagnetic signals and things like this. The other story which I like to refer to is one by Robert Forward, which was a Dragon's Egg, I think was the name of the story, where there was a neutron star which came close to the sun, and the people on the Earth went to explore it, and it turned out that there were living beings on this neutron star, which instead of using chemistry, they used nuclear processes. And this means that their lives and evolution took place millions of times faster than us. And how you can make a story with this complete imbalance was an amazing achievement, I thought. But they even had a religion which took place in the Cheelers, which were the inhabitants of this neutron star. And when the Earth came close to them, they built their complete religion on the star, which appeared, you see, in the. So
do you think it's? I mean, these are obviously stories, but do you think it's possible, in a sense, that some sort of conscious reality could exist even in the absence of the physical sort of carbon-based life that we obviously need?
It could have been done very differently, in a totally different. You see, there are many different parts of the universe where the physics is very different from what it is on the Earth. And maybe a different kind of life could have evolved there, and I have no idea. Just that we don't know. There are puzzles,
right,
which look like coincidental things. And one of the first ones was Hoyle's thing about the energy level of carbon, which hadn't been there. Then you couldn't have got beyond evolution.
Well, Bill, what's your response to these sorts of ways of dealing with the fine-tuning?
Well, this is fascinating to me because, as I understand you, Roger, you're not advocating either physical necessity nor chance via the multiverse hypothesis and self-selection effect, nor design, but rather you would simply deny the fact of fine-tuning altogether, that the universe is not fine-tuned for
I think
embodied
deny is too
consciousness.
strong. I say I don't know.
You don't know.
Yeah.
And to me, that is highly implausible. We just find example after example of fine-tuning in contemporary physics, and it seems to me to be a desperate expedient to deny that it exists. In the absence of fine-tuning, there wouldn't even be matter. There wouldn't be chemistry. So the idea that other forms of life would evolve, I think, is logically possible, but it's not, I think, the most plausible solution to the problem.
Well,
For example, the conditions on Earth and the laws of our universe are not only fine-tuned for life, but apparently also for scientific discovery and technological progress, and the anthropic principle cannot explain this fine-tuning. Although this fine-tuning is not as well documented as the fine-tuning for life, here are some resources which support it. Many scientists are convinced of design by the argument from fine-tuning, but most of them still insist that this designer either could not or did not do anything beyond that. But if you believe a creator designed the laws of nature to make life possible, why exclude a priori the possibility that this creator was still somehow involved after that in the creation of humans, especially when then you are forced to believe that the four unintelligent forces of physics alone could have reorganized the fundamental particles of physics on Earth into nuclear power plants, cars, airplanes, and smartphones, as the first part of the video below brings out clearly.
Over 130 years ago, University of California geology professor Joseph LeConte summarized the fossil record.
In successive geological faunas, the change seems rather by substitution than by transmutation. Species seem to come in suddenly, with all their specific characters perfect, remain substantially unchanged as long as they last, and then die out and are replaced by others. Certainly, this looks much like immutability of specific forms and supernaturalism of specific origin.
LeConte also acknowledges that natural selection cannot explain the appearance of new, irreducibly complex features called novelties in his day.
Neither can it explain the first steps of advance toward usefulness. An organ must be already useful before natural selection can take hold of it to improve on it.
After acknowledging that the only direct evidence, the fossil record, does not support the idea of gradual change, and that the only theory ever taken seriously as to the causes of these changes can explain everything except anything new, LeConte nevertheless concludes,
We are confident that evolution is absolutely certain, not evolution as a special theory, Lamarckian, Darwinian, Spencerian, but evolution as a law of derivation of forms from previous forms. In this sense, it is not only certain, it is axiomatic. The origins of new phenomena are often obscure, even inexplicable, but we never think to doubt that they have a natural cause, for so to doubt is to doubt the validity of reason and the rational constitution of nature.
And so in 1888, LeConte acknowledges what will become clear to anyone who follows the modern debate between Darwinism and intelligent design. Evolution is an axiom, and axioms do not need supporting evidence. A 1980 New York Times article on a meeting at Chicago's Field Museum of Natural History of nearly all the leading evolutionists reports,
At issue during the Chicago meeting was macroevolution, a term that is itself a matter of debate, but which generally refers to the evolution of major differences, such as those separating species or larger classifications. Most agree macroevolution is, for example, what made crustaceans different from mollusks. It is the process by which birds and mammals evolved out of reptiles. Darwin suggested that such major products of evolution were the results of very long periods of gradual natural selection, the mechanism that is widely accepted today as accounting for minor adaptations. Darwin, however, knew he was on shaky ground in extending natural selection to account for differences between major groups of organisms. The fossil record of his day showed no gradual transitions between such groups, but he suggested that further fossil discoveries would fill the missing links. The pattern that we were told to find for the last 120 years does not exist, declared Niles Eldredge, a paleontologist from the American Museum of Natural History in New York. Eldredge reminded the meeting of what many fossil hunters have recognized as they trace the history of a species through successive layers of ancient sediments. Species simply appear at a given point in geologic time, persist largely unchanged for a few million years, and then disappear. There are very few examples, some say none, of one species shading gradually into another.
The New York Times writer assures us, however, that all of this does not suggest weakness in the fact of evolution, only in the perceived mechanism. Even if new features consistently appear suddenly in the fossil record and cannot be explained by natural selection, there is no doubt they were the result of entirely natural causes. That is an axiom that cannot be questioned. Leconte's axiom is the strongest argument against intelligent design. It is certainly understandable that Leconte and other scientists are confident that nothing is beyond the reach of their science. In every other field of science, naturalism has been spectacularly successful. Why should evolutionary biology be so different? To explain why evolution is different, so different that it requires a very different type of explanation, we need to look at what you have to believe to not believe in intelligent design. Peter Eurone, in College Physics, writes,
"One of the most remarkable simplifications in physics is that only 4 distinct forces account for all known phenomena."
But can 4 unintelligent forces of physics alone really rearrange atoms into computers and airplanes and science texts? It is difficult to even imagine a more obvious and spectacular violation of the more general statements of the second law of thermodynamics, such as, for an isolated system, the direction of spontaneous change is from order to disorder. But we are all familiar with the standard counter-argument. The Earth is not an isolated system. It receives energy from the sun. Early versions of the second law stated that a quantity called thermal entropy, which measures disorder in the temperature distribution, cannot decrease in an isolated system, but can decrease in an open system. And some scientists generalize this to say that the second law allows any order increase in an open system as long as it is compensated by decreases outside the system. In a Smithsonian Magazine article, Isaac Asimov first acknowledges the apparent conflict between evolution and the second law.
You can argue, of course, that the phenomenon of life may be an exception. Life on Earth has steadily grown more complex, more versatile, more elaborate, more orderly over the billions of years of the planet's existence. From no life at all, living molecules were developed, then living cells, then living conglomerates of cells, worms, vertebrates, mammals, finally man. And in man is a 3-pound brain, which as far as we know is the most complex and orderly arrangement of matter in the universe. How could the human brain develop out of the primeval slime? How could that vast increase in order, and therefore that vast decrease in entropy, have taken place?
But then he uses the usual compensation argument to conclude that there is really no conflict.
Remove the sun and the human brain would have not developed. In the billions of years that it took for the human brain to develop, the increase in entropy that took place in the sun was far greater, far greater than the decrease that is represented by the evolution required to develop the human brain.
Professor Granville Sewell of the University of Texas El Paso has published multiple peer-reviewed articles critiquing the compensation argument. Most recently, in 2017, he published an article in Physics Essays. There he defined X order to be the negative of the entropy associated with the distribution of any diffusing component X. If X is heat, for example, X order is just thermal order. and showed that the equations for entropy change not only say that X order cannot increase in an isolated system, they also say that in an open system, the X order cannot increase faster than it is imported through the boundary. Thus, he argued, the equations of entropy change do not support the illogical compensation idea. Instead, they illustrate the tautology that
if an increase in order is extremely improbable when a system is isolated, it is still extremely improbable when the system is open, unless something is entering which makes it not extremely improbable.
The fact that order can increase in an open system does not mean that computers can appear on a barren planet as long as the planet receives solar energy. Something must be entering the system which makes the appearance of computers not extremely improbable. For example, computers. The whole critique of Asimov's widely used compensation argument is very simple and can be understood through a couple of simple stories. Here is a picture of a neighborhood in Moore, Oklahoma, taken before the 2013 tornado hit. Here is a picture taken right after the tornado. Fortunately, another tornado hit Moore a few days later and turned all this rubble back into houses and cars, as seen in this picture. If we asked you why you don't believe our story about the second tornado, you might say this tornado seems to violate the more general statements of the second law of thermodynamics, such as, for an isolated system, the direction of spontaneous change is from order to disorder. But we could use the compensation argument to reply, Moore is not an isolated system because tornadoes receive their energy from the sun, and the increase in order in Moore caused by the second tornado is easily compensated by decreases outside the system. Various reasons why the development of civilization does not violate the second law have been given, but all of them can equally well be used to argue that the second tornado did not violate it either. The only difference is, there is a theory which is widely accepted in the scientific world as to how civilizations could develop on barren planets, while there is no widely believed theory as to how tornadoes could turn rubble into houses and cars. Nevertheless, suppose we further said that we have a scientific theory that explains how certain rare types of tornadoes, under just the right conditions, really can turn rubble into houses and cars. You doubt our theory? You haven't even heard it yet. If our theory had been studied by the top meteorologists in the world and all agreed that it was plausible, would you take it seriously then? Still no? 2 more stories are needed to complete the picture. Here is a certain Earth-like planet in a certain solar system as it looked about 4 billion years ago. Next is the same location about 10,000 years ago. At its prime, this large city had tall buildings full of intelligent beings, computers, TV sets, and cell phones. It had libraries full of science texts and novels, and airports with jet planes. Scientists explain how civilization developed on this once barren planet as follows. 3 or 4 billion years ago, a collection of atoms formed by pure chance that was able to duplicate itself. These complex collections of atoms were somehow able to preserve their complex structures and pass them on to their descendants, generation after generation. Over a long period of time, the accumulation of duplication errors resulted in more and more elaborate collections of atoms. And eventually, something called intelligence allowed some of these collections of atoms to design buildings and computers and airplanes and write encyclopedias and science texts. Sadly, there's a second story. A few years after these pictures were taken, this planet was hit by a massive solar flare from its sun, and all the intelligent beings died. Their bodies decayed, and their cells decomposed into simple organic and inorganic compounds. Most of the buildings collapsed immediately into rubble. Those that didn't crumbled eventually. Most of the computers and TV sets inside were smashed into scrap metal. Even those that weren't gradually turned into piles of rust. Most of the books in the libraries burned up. The rest rotted over time. And you can see the final result many years later. This time, the second story is natural and believable. It is the first story that is much more difficult to believe. The second story shows what natural causes normally do. They destroy order. While every other natural process tends to turn order into disorder, Darwinists have always believed that natural selection is the one unintelligent process in the universe that can create spectacular order out of disorder. But despite all the claims about the creative powers of natural selection, it has never actually been observed to produce anything new and complex, only devolution. Lehigh University biochemist Michael Behe, in his 2019 book Darwin Devolves, writes,
Darwinian evolution proceeds mainly by damaging or breaking genes, which counterintuitively sometimes helps survival. In other words, the mechanism is powerfully devolutionary. It promotes the rapid loss of genetic information. Laboratory experiments, field research, and theoretical studies all forcefully indicate that, as a result, random mutation and natural selection make evolution self-limiting. Darwin's mechanism works chiefly by squandering genetic information for short-term gain.
So perhaps natural selection of random mutations is like every other unintelligent cause in the universe after all, and tends to create disorder out of order, and not vice versa. Anyone who claims to have a scientific explanation for how unintelligent agents might be able to turn rubble into houses and cars would be expected to produce some very powerful evidence if they want their theory to be taken seriously. The burden of proof should be equally heavy on those who claim to have scientific explanation for how a few unintelligent forces of physics alone could rearrange the basic particles of physics into computers and encyclopedias and Apple iPhones. And there is no evidence that natural selection of random mutations can explain anything other than very minor adaptations.
These forces are very cleverly designed and probably are clever enough to explain chemistry and stars and everything that has happened on other planets, but points 3, 4, and 5 of the video below discuss the 3 problems science must solve to explain how human civilization developed on Earth without further help from this creator. We will see that we are not close to solving any of the 3.
It is often claimed that science is close to understanding how the first simple life form arose through entirely natural processes. To see how baseless this claim is, you only have to realize that with all our advanced technology, we are still not close to designing any type of self-replicating machine. That is still pure science fiction. So how could we imagine that such a machine could have arisen by pure chance, even given a universe with fine-tuned laws and a planet with fine-tuned conditions? When we add technology to such a machine to move toward the goal of reproduction, we only move the goalpost, as now we have a more complicated machine to reproduce. Maybe someday human engineers will design a self-replicating machine like we see everywhere in the living world, but it will not happen in my lifetime, and it will not be simple, and it will certainly not show that such a machine could have arisen without design. Materialists believe they already understand how the first living things evolved into intelligent beings, but they really do not have a clue. To appreciate this, you only have to realize that what they are forced to believe is that the 4 fundamental unintelligent forces of physics alone could have rearranged the basic particles of physics on Earth into tall buildings, computers and cell phones, and airplanes and the internet. As my new video, Why Evolution is Different, brings out, the laws of physics are very cleverly designed and probably can explain everything that has happened on other planets, but they are obviously not clever enough to explain by themselves the development of computers and cars and Apple iPhones. This video also points out how similar the fossil record is to the development of human technology, with obvious similarities between each new invention and previous designs, but with large gaps where major new features appear for the same reasons. Gradual development of the new organs that gave rise to new orders, classes, and phyla would require the development of new but not yet useful features. So Darwinism could not explain the development of these new features even if they did occur gradually, and they don't. Here is a picture of 3 children in the 1950s. One of them is me, the other 2 are not. I saw the world from inside one of these children. I saw every picture that entered through his eyes. I heard every sound that entered through his ears, and when he fell on the sidewalk, I felt his pain. How did I end up inside one of these children? This is a question that rarely seems to trouble evolutionists. They talk about human evolution as if they were outside observers and never seem to wonder how they got inside one of the animals they are studying. They consider that human brains are just complicated computers, and so to explain how we got here, they just have to explain how these mechanical brains evolved. But even if they could explain how animals with mechanical brains evolved out of the primeval slime, that would leave the most important question, the one evolutionists never seem to even wonder about, still unsolved. How did I get inside one of these animals?
The first problem is the origin of life. Science still cannot explain the origin of life. Note that the debate between Rice University chemist James Tour and origin of life researchers is over whether or not we are clueless about the origin of life. I'm now going to read a few paragraphs from the beginning of my 2023 Biocosmos article, which is relevant here. With all our advanced technology, we are not close to producing human-engineered self-replicating machines. This is significant because it is widely believed that the first self-replicators on Earth must have arisen through chance chemical processes, it being impossible to appeal to natural selection of replication errors before anything could self-replicate. To better appreciate the enormous difficulties in designing such machines, and thus the difficulties in understanding how the first living things arose on Earth, let's think about what would be required to build, say, a self-replicating Model T car. We know how to build a simple Model T. Now let's build a factory inside this car so that it can produce Model T cars automatically, and call the new car with the Model T factory inside a Model U. A car with an entire automobile factory inside, which never requires any human intervention, is far beyond our current technology, but it doesn't seem impossible that future generations might be able to build a Model U. Of course, the Model U cars are not self-replicators because they can only construct simple Model Ts. So let's add more technology to this car so that it can build Model Us, that is, Model Ts with car building factories inside. This new Model V car, with a fully automated factory inside capable of producing Model Us, which are themselves far beyond our current technology, would be unthinkably complex. But is this new Model V now a self-replicator? No, because it only builds the much simpler Model U. The Model V species will become extinct after 2 generations because their children will be Model Us and their grandchildren will be infertile Model Ts. So back to work, and each time we add technology to this car to move it closer to the goal of reproduction, we only move the goalposts because now we have a more complicated car to reproduce. It seems that the new models would grow exponentially in complexity, and even if we were able to engineer self-replicating cars, it is hard to imagine that without any human maintenance, these cars could keep reproducing themselves for more than a few generations before errors accumulate to the point that all replication halts. And here we have ignored the very difficult question of where these cars get the raw materials they need to supply their factories. Some will object here that the first living things may have been much simpler than self-replicating cars. It is widely believed that you only need to explain how very simple self-replicators could have arisen through chance chemical processes, because then natural selection of the resulting duplication errors could take over and explain how self-replicators far more complex than cars could have arisen. But even if we could explain the appearance of simple self-replicators, imagining trying to design self-replicating cars may help us appreciate the enormity of the difficulties facing any scientific explanation, let alone one which relies on replication errors, for the unimaginably complex self-replicators that we see everywhere in the living world. Then I go on to say, well, let's imagine something much simpler. like a self-replicating cardboard box, and I show that the same thing happens then. The second problem is the evolution from the first life form to complex animals. Darwinists believe they already understand how this happened, but in fact Darwin's implausible explanation for evolution becomes even more implausible with each new biological and biochemical discovery. It is still popular today only because of LeConte's axiom and the fact that evolution doesn't look like the way we think a creator should have designed things. But the fossil record does look a lot like the development of human technology, with obvious similarities between each new invention and previous designs, but with large gaps where major new features appear, as brought out in the second half of my video, Why Evolution is Different.
How did such an implausible theory as Darwinism ever get to be so popular? There are two reasons: LeConte's axiom and the similarities between species, which suggest common descent. In many people's minds, these similarities not only prove common descent, they prove that evolution was the result of entirely natural processes, even in the absence of any evidence that natural selection can explain the major steps of evolution. But the similarities do not really tell us anything about the causes of evolution, and there is an alternate explanation for these similarities. Harvard paleontologist George Gaylord Simpson writes,
"It is a feature of the known fossil record that most taxa appear abruptly. They are not, as a rule, led up to by a sequence of almost imperceptibly changing forerunners, such as Darwin believed should be usual in evolution. This phenomenon becomes more universal and more intense as the hierarchy of categories is ascended. Gaps among known species are sporadic and often small. Gaps among known orders, classes, and phyla are systematic and almost always large. These peculiarities of the record pose one of the most important theoretical problems in the whole history of life. Is the sudden appearance of higher categories a phenomenon of evolution or of the record only, due to sampling bias and other inadequacies?"
French biologist Jean Rostand wrote,
"It does not seem strictly impossible that mutations should have introduced into the animal kingdom the differences which exist between one species and the next. Hence it is very tempting to lay also at their door the differences between classes, families, and orders, and in short the whole of evolution. But it is obvious that such an extrapolation involves the gratuitous attributions to the mutations of the past of a magnitude and power of innovation much greater than is shown by those of today."
In a 2000 Mathematical Intelligencer article entitled A Mathematician's View of Evolution, Granville Sewell wrote the following.
If archaeologists of some future society were to unearth the many versions of my PDE solver which I have produced over the last 20 years, they would certainly note a steady increase in complexity over time, and they would see many obvious similarities between each new version and the previous one. In the beginning, it was only able to solve a single linear steady-state 2D equation in a polygonal region. Since then, PDE-2D has developed many new abilities. It now solves nonlinear problems, time-dependent and eigenvalue problems, systems of simultaneous equations, and it now handles general curved 2D regions. An archaeologist attempting to explain the evolution of this computer program in terms of many tiny improvements might be puzzled to find that each of these major advances, new classes or phyla, appeared suddenly in new versions. For example, the ability to solve 3D problems first appeared in version 4.0. Less major improvements, new families or orders, appeared suddenly in new subversions. For example, the ability to solve 3D problems with periodic boundary conditions first appeared in version 5.6. In fact, the record of PDE-2D's development would be similar to the fossil record, with large gaps where major new features appeared and smaller gaps where minor ones appeared. That is because the multitude of intermediate programs between versions or subversions which the archaeologists might expect to find never existed because, for example, none of the changes I made for edition 4.0 made any sense or provided PDE-2D any advantage whatever in solving 3D problems or anything else until hundreds of lines had been added.
To our modern minds, the similarities between species may suggest natural causes. The argument is basically, this doesn't look like the way God would have created things, an argument used frequently by Darwin in Origin of Species. But if the history of life does not give the appearance of creation by magic wand, It does look very much like the way we humans create things, through testing and improvements. In fact, the fossil record does not even support the idea that new organs and new systems of organs arose gradually. New orders, classes, and phyla consistently appear suddenly. We see this same pattern of large gaps where major new features appear in the history of human technology. For example, if some future paleontologist were to unearth two species of Volkswagens, he might find it plausible that one evolved gradually from the other. He might find the lack of gradual transitions between automobile families more problematic, for example, in the transition from mechanical to hydraulic brake systems, or from manual to automatic transmissions, or from steam engines to internal combustion engines. But if he thought about what gradual transitions would look like, he would understand why they didn't exist. There is no way to transition gradually from a steam engine to an internal combustion engine, for example, without the development of new, but not yet useful, features. He would be even more puzzled by the huge differences between the bicycle and motor vehicle phyla, or between the boat and airplane phyla. But heaven help us, when he uncovers motorcycles and hovercraft, the discovery of these missing links would be hailed in all our newspapers as final proof that all forms of transportation arose gradually from a common ancestor, without design. Some people say, of course cars cannot evolve because they cannot reproduce. Well, designing any type of self-replicating machine is still far beyond our current technology. When we add technology to such a machine to get closer to the goal of reproduction, we only move the goalposts because now we have a more complicated machine to reproduce. So how could we imagine that such a machine could have arisen by pure chance? Nevertheless, imagine that we did manage to construct a fleet of cars that contained completely automated car-building factories inside, with the ability to construct new cars, and not just normal new cars, but new cars containing automated car-building factories inside them. If we left these cars alone and let them reproduce themselves for many generations, is there any chance we would eventually see major advances arise through natural selection of the resulting duplication errors? Of course not. We could confidently predict that the whole process would grind to a halt after a few generations without intelligent humans around to fix the mechanical problems that would inevitably arise, long before we saw duplication errors, which held any promise of advances. Devolution is natural. Evolution is not. That it seems even superficially plausible that random mutations could produce major improvements relies completely on the observed but inexplicable fact that while they are awaiting rare favorable mutations, living species are able to preserve their complex structures and pass them on to their descendants without significant degradation, generation after generation. We are so used to seeing this happen that we don't appreciate how astonishing it really is. But if we saw cars reproducing themselves, generation after generation, we might conclude that this actually made the development of cars even more difficult to explain without design. The similarities between the history of life and the history of technology go even deeper. Although the similarities between species in the same branch of the evolutionary tree may suggest common descent, similarities also frequently arise independently in distant branches, where they cannot be explained by common descent. For example, in their Nature Encyclopedia of Life Sciences article on carnivorous plants, Wolf Eckerd Lenig and Heinz Albert Becker note that
carnivory in plants must have arisen several times independently of each other. The pitchers may have arisen 7 times separately, adhesive traps at least 4 times, snap traps 2 times, and suction traps possibly also 2 times. The independent origin of complex, synorganized structures, which are often anatomically and physiologically very similar to each other, appears to be intrinsically unlikely to many authors, so that they have tried to avoid the hypothesis of convergence as far as possible.
These carnivorous traps, by the way, are all good examples of irreducible complexity. Many features must work together almost perfectly before they can catch and digest victims. Convergence suggests common design rather than common descent. The probability of similar designs arising independently through random processes is very small, but a designer could, of course, take a good design and apply it several times in different places to distantly related species. For example, to give bats and dolphins echolocation abilities. Convergence is a phenomenon often seen in the development of human technology. For example, Ford automobiles and Boeing jets may simultaneously evolve similar new GPS systems. The history of life on Earth appears strikingly similar to the way humans design things, through careful planning, testing, and improvements. As intelligent designers ourselves, we should recognize it when we see this in nature.
There are large gaps in the fossil record where major new features appear, for the same reasons that there are large gaps in the history of human technology where major new features appear. Gradual development of the new organs and new systems of organs that gave rise to new orders, classes, and phyla would require the development of new but not yet useful features. So Darwinism could not explain the development of these new features even if they did appear gradually, and they don't. A 2022 article in The Guardian shows that our objections to Darwinism are still valid today. Strange as it sounds, scientists still do not know the answers to some of the most basic questions about how life on Earth evolved. Take eyes, for instance. Where did they come from exactly? The usual explanation of how we got these stupendously complex organs rests upon the theory of natural selection. You may recall the gist from school biology lessons. If a creature with poor eyesight happens to produce offspring with slightly better eyesight thanks to random mutations, then that tiny bit more vision gives them more chance of survival. The longer they survive, the more chance they have to reproduce and pass on the genes that equip them with slightly better eyesight. Some of their offspring might in turn have better eyesight than their parents, making it likelier that they too will reproduce, and so on. Generation by generation, over unfathomably long periods of time, tiny advantages add up. Eventually, after a few 100 million years, you have creatures who can see as well as humans or cats or owls. This is the basic story of evolution, as recounted in countless textbooks and pop science bestsellers. The problem, according to a growing number of scientists, is that it is absurdly crude and misleading. For one thing, it starts midway through the story, taking for granted the existence of light-sensitive cells, lenses, and irises without explaining where they came from in the first place. Nor does it adequately explain how such delicate and easily disrupted components mesh together to form a single organ. And it isn't just eyes that the traditional theory struggles with. The first eye, the first wing, the first placenta, how they emerge. Explaining these is the foundational motivation of evolutionary biology, says Armin Moksek, a biologist at Indiana University, and yet we still do not have a good answer. This classic idea of gradual change, one happy accident at a time, has so far fallen flat. The carnivorous plants are all good examples of irreducible complexity, that is, of features which would not make any sense to evolve gradually. One of them is described in Plants and Environments as follows. The aquatic bladderworts are delicate herbs that bear bladder-like traps 5 millimeters or less in diameter. These traps have trigger hairs attached to a valve-like door, which normally keeps the trap tightly closed. The sides of the trap are compressed under tension, but when a small form of animal life touches one of the trigger hairs, the valve opens, the bladder suddenly expands, and the animal is sucked into the trap. The door closes at once, and in about 20 minutes, the trap is set ready for another victim. Irreducible complexity is ubiquitous in living things, but usually Darwinists can imagine 2 or 3 far-fetched, useful intermediate stages and consider the problem solved. The carnivorous plants are special only in that, quote, it appears to be hard even to imagine clear-cut selective advantages for all the thousands of postulated intermediate steps in a gradual scenario for the origin of the complex carnivorous plant structures examined above, according to an article on carnivorous plants. This article by Wolf Eckert Linisch and Heinz Albert Becker of the Max Planck Institute for Plant Breeding Research in Cologne, Germany, includes a discussion of the aquatic bladderworts mentioned earlier. They quote a 1959 article, "Even a perfect suction trap displaying the astonishing ability to rapidly catch animals would have no advantage in the struggle for life because the prey would not be digested. Conversely, the production of highly effective digestive juices would be of no avail for the tip of a leaf as long as it could not capture the prey, which is absolutely necessary. But even if suction trap and digestive juices cooperated, nothing would be gained in the struggle for life. The dissolved proteins must also be absorbed and metabolized to species-specific proteins. The formation of the suction trap requires the perfect cooperation of many different genes and developmental factors. At the end, a benefit is reached in the struggle for life, but not by any evolutionary stage." They continue, "Knockway concluded that none of the contemporary evolutionary theories was able to answer these questions, proposing that the answer might lie outside the present scientific paradigms." The third problem is the origin of intelligent, conscious humans. If you believe that humans are the result of a purely mechanical process such as natural selection of random mutations, you are forced to believe that we are just machines, as brought out in point 5 of the video below. But I am not just a machine, so even if unintelligent forces could explain the appearance of complex animals, these forces cannot explain how I got inside one of these animals.
Here is a picture of 3 children in the 1950s. One of them is me, the other 2 are not. I saw the world from inside one of these children. I saw every picture that entered through his eyes, I heard every sound that entered through his ears, and when he fell on the sidewalk, I felt his pain. How did I end up inside one of these children? This is a question that rarely seems to trouble evolutionists. They talk about human evolution as if they were outside observers and never seem to wonder how they got inside one of the animals they are studying. They consider that human brains are just complicated computers, and so to explain how we got here, they just have to explain how these mechanical brains evolved. But even if they could explain how animals with mechanical brains evolved out of the primeval slime, that would leave the most important question, the one evolutionists never seem to even wonder about, still unsolved. How did I get inside one of these animals? For thousands of years, nearly everyone in every corner of the world looked at plants and animals and said, "These things are obviously designed. I wonder who designed them." Only the modern scientist, overconfident from so much success in unraveling other mysteries, says, "These things sure look like they were designed, and the deeper we dig, the more designed they look, but who designed the designer? Nothing can possibly be beyond the reach of our science, so if we can't explain where the designer came from, he can't exist." For many years, materialists avoided the parallel question of who designed matter and energy by saying they have always existed. But in the last century, it was discovered that matter and energy and space and time did begin suddenly with a big bang about 14 billion years ago. What came before the Big Bang? Even if before the beginning of time, as we know it, is not meaningful in a temporal sense, it is still meaningful in a causal sense. It's because out of nothing comes nothing. There has to be some first cause. Whether this first cause is intelligent or unintelligent, there is by definition no hope of ever explaining it in terms of earlier causes. Materialists can say that their currently preferred universe-generating mechanism needs no explanation because it is eternal, but we can equally say our designer needs no explanation because he is eternal. So why not assume a first cause that can explain what was caused? A well-designed universe with physical laws that are extremely fine-tuned for the magnificently designed plants and animals, and intelligent, conscious humans that arose on our magnificent earth.
The sixth and last point in my video have to do with the Big Bang. which says that the universe had a beginning, and since there were no natural causes before nature came into existence, science cannot ever hope to explain this beginning. Note, if it is hard to believe the universe had a beginning, it is equally hard to believe it did not. For example, if it were infinitely old, shouldn't all stars have burned out long ago? How long ago? 1 trillion years ago? Why not long before that?
How does something come out of nothing? How do we have a universe that comes out of nothing?
Astronomers believe there are 2 trillion galaxies in the observable universe. Scientists are still trying to figure out how all of this arose, seemingly out of nothing.
Well, it turns out if you apply quantum mechanics to gravity, then in fact space itself becomes dynamical, and universes, spaces themselves and time can pop into existence where there was none before. So you can create whole universes where there was no universe before. And indeed, in that way, you might imagine creating a universe from literally nothing. Whole universes from literally nothing out of existence.
Out of nothing.
Whole universes nothing.
Wait, our universe popped into existence from literally nothing? There is no cause for all of this? So, straight up nothing. No matter, no creator, then poof, the universe? That's actually the story some atheist scientists are peddling right now. Sounds pretty desperate to me. Stephen Meyer, a philosopher of science and best-selling author, explains how atheists got backed into this corner.
It was generally assumed by most physicists prior to the 1920s and 30s that the universe was eternal and therefore self-existent, that it had always been here and really didn't require an explanation. There was one physicist said that an infinitely old universe would relieve us of the necessity of explaining the origin of the universe at any finite time in the past.
But then, the idea of an eternal universe was challenged by a pair of surprising discoveries. First, it became clear that almost all the galaxies in the universe are moving away from us. Then it got weirder. 2 guys figured out that generally the farther a galaxy is from us, the faster it's moving away. One was a Belgian physicist and Catholic priest, Georges Lemaitre. The second was American astronomer Edwin Hubble. Drawing on Albert Einstein's general theory of relativity, they then realized that space itself is expanding. Physicist Brian Miller explains why.
Let me use an analogy. If you have a balloon and you imagine putting dots on that balloon to represent galaxies, and then that balloon inflates, what happens is all the dots move away from each other. And dots that are further apart will move away from each other even faster. And that's exactly the sort of evidence we see in our universe.
This discovery suggests that if you reverse time, like a movie running backward, then all the galaxies would draw back together to a single point, which led to a conclusion that some scientists didn't really want to face.
The universe has been expanding from a finite beginning point, where not only matter and energy, but time and space itself began.
Today, scientists call this first moment of the universe the Big Bang.
All started with the Big Bang.
The Big Bang theory means the universe is not eternal after all. It has a beginning. Even more radical, the Big Bang implies that the cause of the universe must be something non-material.
The Big Bang shows that all of time, matter, space, and energy started at a single moment in the past. Therefore, whatever started it has to be outside of time and space.
You can't posit a materialistic explanation because there's no matter there before the beginning to do the causing.
Many scientists initially resisted the Big Bang, including Einstein, whose theory partly inspired the idea.
He really didn't want at that point in his career to think about the beginning of the universe because he didn't want to think about what would be necessary to explain the origin of the universe if we're talking about all of matter, all of energy, all of space and time.
Einstein eventually accepted the Big Bang theory, but others went on searching for an option that would fit the data without requiring an actual beginning. One that grabbed a lot of attention was the oscillating universe model.
The universe would be expanding outward, but then as the expansion slowed, the matter in the universe by gravitational force would cause the universe to recollapse. But once it recollapsed, then by some unknown mechanism, it would expand again. So you'd get a series of big crunches followed by big bounces. That theory ran into two big problems. The first was it was discovered that there was not enough matter in the universe to cause the universe to recollapse. And secondly, it was determined by thermodynamic analysis. The energy available to do work would diminish with each successive cycle. It would be kind of like a ball bouncing to the ground, and finally it would damp out where there's no more bounces.
Who's going to get it? They drop it. Oh, man.
So the oscillating universe model was a big fail. And actually, all the attempts to evade a true cosmic beginning ran into serious problems. The evidence for the Big Bang kept piling on until most scientists accepted it. Some scientists, however, found themselves facing serious doubts, not about science, but about atheism. World-renowned astronomer Robert Jastrow didn't believe in God, but he found it hard to get around what the Big Bang seemed to be telling him.
So there is a beginning, there is a point in time from which it all started. And that's a remarkable thing because it has a very strong theological flavor to it. And that intrigued me because I am an agnostic, and if there was a beginning, a moment of creation in the universe, then there was a creator.
Of course, a lot of scientists still resist going where the science seems to be leading. Take physicist Stephen Hawking. Before his death, he proposed a new argument against the need for a cosmic creator.
Because there is a law such as gravity, the universe can and will create itself from nothing.
Now, when I first read that, I was staggered because it's self-contradictory to start with. Because there is a law of gravity, because there is something, the universe can create itself from nothing. That's a flat contradiction. And then to say the universe can create itself, that's logical nonsense. If I say that X creates Y, roughly speaking, I'm saying if you've got X, you may in the end get Y. But if I say X creates X, then that simply proves to me that nonsense remains nonsense even if high-powered scientists say it.